Good morning, everyone, and welcome to another Jaltest webinar. Today, we are going to talk about probably the most relevant technical implement in the off-highway industry, that are the after-treatment systems. Okay, a new word that started in the beginning of this century with the exhaust gas recirculate, EGR, and is still adding more components, sensors, and ECMs to our equipment in order to prevent and reduce the carbon dioxide and the oxide of nitrogen emissions, okay? So the NOx and the CO2, okay? So today we will start discussing about how these new systems are impacting the way we are repairing and the evolution of this technology, okay? So we are gonna have an overview on the specifications of the off-highway after-treatment systems and how is nowadays essential to have a diagnostics tool like Jaltest Diagnostics, okay, in order to be able to work in all these new components and to keep the machines working at its best condition, okay. So after seeing the technical implementations, the technology, we are going to have an overview on the maintenance checks and most key actions that are needed to keep this equipment working. And also we are going to finish with where we are going, okay? So what is coming to the off-highway industry, okay? The technology that we are going to see in the following years. Okay, so let's start with the off-highway challenges. First of all, the reasons of the appear of these after-treatment systems is because two things, okay? The first one is the increase of regulation, okay? The increase of emission control due to new legal standards. In this case, in the off-highway industry are the tiers. We started with the tier 1 and now we are in the tier 5, okay? So these legal standardizations started in Europe and then in the United States and try to reduce the emissions of this equipment, okay? Then also we have a demand. The customers are demanding for more social responsible companies in order to work with them. Okay, so we are having a change of the value of our customers. Okay, so they are more looking for this efficiency and these eco-friendly companies and reduction of emissions. Okay. The second fact that we have is the increase of technology. Okay, so in this case, well, we have seen how how we find more electronic components in the engines. We are going to have an images of this, of the evolution of our engines, and how we now have increased the monitoring of the performance of the engine. Okay, we have more sensor, more components, and we have more control on the machines and its efficiency. Okay, but how does impact in our repairs? Well, in other words, the number of components, sensors, and solutions has impacts in the way we are repairing in the shops, because nowadays we need diagnostics tool to be able to work with these components. Okay, so for example, for the off-highway repairs, we find that nowadays the repairs are more expensive because there are more components we need to replace. We need more spare parts. We need more sensors. We need more expertise in terms of electromechanics, and now the repairs are becoming more complex, okay, due to having more systems in the engines. Okay, so another thing interesting in the off-highway industry that we have seen with our customers is that the third-party dependency. Okay, so many end users, many fleet owners and shops are depending on third parties to perform the capabilities that they should by their own in terms of repairing after treatment system. And that's why, because they do not have the right tools or the right knowledge about these specifications that, as we will see, are very different from the on-road industry. Okay, so at the end of the day, we are finding a world in which the repairs are less freedom than used to be before, when the system were more mechanical. Okay. So, well, as I said before, nowadays we need a good diagnostics tool to allow us to communicate with these ECNs, with these computers that we have in the after treatment systems. Okay, so let's go back a little bit to see the evolution of this situation and to understand better why we are here, what we have, and where we are going. Okay, so we are going to have a look to the different tiers right now and to see how that impacts in the systems and components that we have in the engines. Okay, so as we can see in this slide, when these regulations started in the off-highway industry, uh, it is something that happened following the on-highway industry. In the on-highway industry, the first standardization or the first regulation started in the 80s, and instead in the off-highway we find the tier 1 in 1996. Okay, followed by the tier 2, tier 3, and as you can see, the reductions of level of soot particles and NOx. Well, are decreasing a lot in the last years, especially since the last 15 years. Okay, so on the top of the slide we can see these two elements mentioned before, the oxides of nitrogen and the soot particles. And in the history of the highway industry, we have passed from 15 grams of oxides of nitrogen per kilowatt hour to less than 0.5 grams. That is the amount of NOx that we are emitting nowadays per machine in the average. And from 1 gram to 0.015 grams per kilowatt hour regarding the particles in the air, which includes, of course, the CO2, okay, and other particles, okay. So in other words, we have passed from mechanical engines in which we didn't control the emissions nor the efficiency to electronic engines in which we have dozens of sensor components and additional systems that monitor the whole performance of the engine. As you can see here in our example in Caterpillar, we have 3 engines. Okay, so the first one is the first Caterpillar engine that was the diesel engine. Sorry, that was launched in 1931. And then we have one engine that is 60 years younger, that is the 3406C in the 19s. And as you can see, there are not many components or many elements. So we can understand that in 60 years of diesel history, there will not be many technological or technologies developments. Okay, but everything changed in the last 20 years. And as you can see, we have another engine that is a final tier 4 Caterpillar C18, in which we can see the after treatment system, a lot of components, ECMs, etc. Okay, so well, we have new systems, new technology, new computers, and repairs that have become more complex. Okay, so let's have a look to those systems to understand better what they are doing in the engine and when they appear. Okay, so as I said at the beginning of the presentation, the first one was the EGR, the exhaust gas recirculation. And as its name says, these components take the gas combusted and redirect it back to the engine again for a second combustion in order to improve the efficiency of the engine and reduce the emissions. So we are saving fuel doing this action. Okay, so this component was implemented at the beginning of the century, and the standardization took place accompanied by another element that is the DOC, okay, the diesel oxidation catalyst, okay. Sometimes we confuse this component with the DPF as a whole system. As you can see right now, if you see my arrow, this would be the DPF and this the DOC are two different systems and they have two different functions, but people used to think that they're a complete piece, but no. The first one was the DOC, and as we will see, we can find many machines with only having the DOC instead of having a DPF, okay. So the DOC is an after treatment component that is designed to convert carbon monoxide, so CO, and hydrocarbons into carbon dioxide and water. Okay, so we convert CO into CO2 and water. This catalyst the catch also carbon and diesel residues. Okay. Another, well, this started in the tier 3. Okay, so it was 2004. Then in the Tier 4 interim in 2007, we have the integration of the most famous after-treatment system, that was the DPF, the diesel particulate filter, a filter that traps particulate matter such as soot and ash. Okay, so this filter is the one that continue the after treatment. So it's the following one after the DOC. So after the right after the DOC, we find the DPF, this filter. Okay, so the first one was a catalyst, and the second one is a filter. Also, in those years, in the 2007, in this tier 4 interim, we are gonna have the implementation of the OBD2 technology that allow by a simple, it's a development of the communication between the components, okay, and allowing a simple plugin test that will only take seconds to be performed. Plus, so this allows us to detect emission problems quickly. Okay, so this development on the communication between the elements of the engine, it's true that in the off-highway industry is not standard. Okay, it's not like in the on-highway where we find that all the components communicate by J1939 protocols. In the off-highway, we have more protocol. It's a little bit more complex, but it's true that nowadays most of the systems communicate with this technology. This is a faster communication and increase, of course, the efficiency of the engine and allow the ECMs to adapt the performance to reduce emissions, reduce fuel consumption, and, well, at the end of the day, increase the operation of the engine. Okay, so this was another element that started in the 2007. After that, well, we have the apparition of the SCR, okay, the selective catalytic reduction, that makes also a great impact in the off-highway industry. These systems basically what does is injecting DEF, so diesel exhaust fluid, to reduce the NOx particles in the exhaust gases. Okay, so this DEF has a chemical process in which we convert these NOx gases into N2 and H2O. Okay, so we convert the NOx into N2 and water. Okay, so this appeared in 2010. Okay, and this final tier 4 have a great impact in the emissions of the NOx emissions. Okay, so here we are checking in the graphs the soft particles. So you see that we have reduced it, but to be more clear with this final tier 4 standardization, we should have a look to the emissions of NOx. Okay, because this element, the SCR, has a greater impact on the NOx particles. Okay, so we are only taking care of the soft particles, but if we do a graphic on the other one, we are going to see again same reduction of NOx, for example with the AGR, but a great one in 2010 with the final tier 4. Okay, an interesting fact about these tiers that make the difference between the off-highway and the on-road industry is that due to the technology and the variety of engine manufacturers and engine size as well, okay, so depending on the motorization, we can find many engines that, following the standards, I mean, working under the regulation, don't have some of these systems. So in other words, when we are working with on-highway engines, if we are checking an engine of 2017, for example, we are going to have a EGR, a DOC, a DPF, and a SCR. But in the off-highway industry, we can find a 2021 engine without a DPF, for example. Okay, so this is also something important that we have to highlight in the off-highway industry, because sometimes when we are repairing new machines, we are looking for systems that are not there, and especially when we are working with aftermarket solutions that sometimes display and show some tests and some actions that are not available in our machines, basically because there is no DPF, for example. So with Jaltest, we manage this. We have control of the specific motorization and the size of your engine, and we are only showing you the actions that are available for your variant, okay, for your engine. So you will not find DPF regions when there is not DPF. Okay, so this is very important when we are working with the off-highway after treatment systems. Okay, so to finish off this technology evolution, this standardization evolution, the tiers, I would like to mention the new tier 5, that started in 2020, because, well, the systems mentioned before reduce the carbon monoxide, so the CO and the NOx, but they don't do anything with the CO2. So nowadays the effort of the industry are going more to reduce the impact of these CO2 emissions by monitoring the combustion. So we are improving the injection, we are having more sensors and more components that are being added to our engines in order to perform a better combustion, in order to be more efficient. So for example, other solutions that are starting are like the telematic solutions in order to adjust and improve the driving or working habits of these machines. So the goal nowadays with the tier 5 and the following tiers are going to be in that direction until the zero emissions, that is the final goal of the industry and the world itself. So to reduce uh, uh, these problems that we are having across the world. Okay. So in order to be able to understand better why the off-highway industry is particular in terms of after treatment technology, I would like to have an overview on the specific technology that is displayed or developed in the main makes of the industry. So for example, in the slide you have in front of you, we have a SCR ECM. So we have the computer that manage the ECR technology. According to this technology, according to this computer, we have many different ECMs. So this is something different between the off-highway and the on-highway, because the one we have in the screen right now, that is the Diagnostics 2.2, is the predominant in the off-highway industry. It's manufactured by Bosch, and it's a system that controls the SCR of many makes, like for example, Cummins engine, Deutsch engines, Case, New Holland, and John Deere. However, while in the on-road industry, we can find mainly two ECMs, one manufactured by Bosch, that is the one you have in your screen, and another one manufactured by Cummins, that is the EcoFit UL2 in the new Cummins engines. In the off-highway, we find many others computers, many other ECMs. So we can find also this EcoFit UL2, for example, in Cummins engines from 2017. But we can also find the previous Diagnostics 2.1, that is a system that is popular in Europe and is not common in the on-highway industry in America. But just in the off-highway. So this ECM can be found in Mercedes engines, for example. The differences between the Diagnostics 2.2 and the 2.1 is that the old one works with compressed air, while the 2.2 version is a SCR that works with a DEF pump. So you are maybe more confident with this 2.2 version because it's the most popular in our market. But there is another one that works with compressed air and is available in many Mercedes engines in the off-highway industry. Well, we have other SCR ECMs in Volvo Construction, in Yanmar, and other Asian manufacturers. So it's something that we have to take care, because we are going to find different technology, different ECR systems in the off-highway industry. So if you are working with both on-highway and off-highway, you are going to realize that the technology is different. So it's something that we have to take care. But there are more differences regarding the technologies and developments. So every manufacturers in the off-highway industry develop their own after treatment system with different components. So for example, here I bring an example from Caterpillar, that is the leader of the off-highway engines manufacturers, and it's something that is available not only in Caterpillar but also in Perkin, in which we can find a unique component for this manufacturer, that is the after treatment regeneration device. Okay, so this device is the ARD, and it's a component located right before the DPF, replacing the seventh injector. Okay, so as you may note, this after treatment systems has an injector to that inject fuel in the after treatment in order to be able to rise the temperature to oxidize the particles. Okay, but in Caterpillar, instead of having this injector, we have the ART that ignite the fuel to burn the soot from the DPF core. Okay, so in Caterpillar bigger engines, for example, this ARD system has its own ECM. Okay, so in every Caterpillar big engine with a big horsepower, we are going to find an ECM, a specific computer to manage these components. So this is something we have to take care when we are repairing, because sometimes we are going to need system checks and different actions that we need to actuate directly to the ARD ECM. Okay, in the small one, we are going to manage the ARD component through the computer ECM. So like the normal thing, okay, when we are uh, working with these injection elements of the after treatment, but we have to take care with the big one. Okay, the reason of this development was that Caterpillar found difficult to rise the temperature by injecting only diesel in the after treatment. So because of that, these systems are too big. So sometimes it's difficult to rise those temperature to burn the soot. So instead of having an injector, they have a this IRD system that do the combustion itself. Okay, so this IRD is a completed combustion system with a spark plug. Okay, so we are going to have a fire there in the after treatment. Okay, following this line of particularities, I would like to conclude with these Deutsch engines. Okay, where we find an interesting development in the final tier 4 engines and tier 5 engines, and probably in the future after treatment systems of this manufacturer. Okay, and this is a particular DOC. Okay, an open filter system in the DOC. This is a unidirectional DOC that, unlike the conventional DOC catalyst, allows to flow the air without opposition, so avoiding the need of having to increase the pressure of the exhaust gases in the after treatment. Okay, so we do not need to rise to increase the pressure in this DOC, because these systems through technology already carry out the action or the function of the DOC. Okay, in these systems, and this is the particularity, we are gonna find the continuous regeneration trap catalyst, that is the CRTC. Okay, that is a filter that performs a passive regeneration called CRT effect. Okay, so this effect is a chemical reaction in the catalyst. So I mean, instead of having a filter itself, we are gonna find a chemical reaction in which it's like having a continuous region in the DOC. Okay, so we are gonna have these reactions because the DOC generate NO2 particles in the previous catalyst, which turns the NO into NO2. So this chemical reaction is another advantage of this system, and not only allow to reduce the emission, but also reduce the engine load needs. Okay, so I mean, due to this efficiency in the after treatment, we are going to reduce the operation of the engine working more efficiency. So in other words, the increase of efficiency of the DOC makes that some of these final tier 4 and tier 5 engine don't need anymore a DPF. Okay, so the DPF becomes optional, because we, with the DOC and the SCR, as you have in the screen, with these basic elements, we already comply the expected emissions standards. Okay, so this development represents in some ways the potential evolution of the control of emissions in the off-highway and heavy-duty industry, in which by controlling the performance and the efficiency of the systems that we have, like for example, in this case, the DOC, by creating a chemical reaction, we reduce and simplify the combustion system, the combustion process, and the after treatment elements. Okay, so it is very possible that the industry is going to a world without a DPF and other after treatment systems. Okay, so by increasing this with sensors and more elements, we simplify the process and we reduce the emissions. Okay. Well, however, nowadays we still have to deal with these systems. So for this reason, it is very important to have a good tool, as I said before, that can communicate with all the specifications and technologies that we have seen during this presentation. Okay. Well, our recommendation is Jaltest Offhighway because it's the all makes and all system diagnostic solution that allows you to work in all the after treatment manufacture with the best coverage for the off-highway engines and after treatment systems in the market. Okay, so well, in this slide we have summarized some of the most important checks uh, that some of the most important checks and key actions that customers, partners, and people of the industry are demanding in order to cover this after treatment system. Okay, so these checks that you have in the screen right now are covered by Jaltest in all makes. Okay, so for example, force regions in both DPF and SCR systems. That is a key action to oxidize the particles by raising the temperatures in the after treatment. Well, I'm sure you know what I'm talking about. Also, for example, the SCR system test to check the performance of all the elements of the SCR, including, for example, the DEF pump test that, as we have seen before, is very popular, this pump in the SCR. And with these checks, we can, well, we can see if we are having a right performance of the pump, a right performance of the SCR, and we can solve some faults that may be active, or even when we have crystallization in the of the DF in the SCR. Due to this system test, we can see where we are having the problem, if it's a sensor, or we are not raising the temperature or the pressure needed to perform the actions. Okay. Also, for example, the delation of the inducement mode. Okay. Well, as you may know, time after time, these machines has this inducement mode that limit the operation of our equipment. So with a right diagnostic solution, diagnostics tool, we are able to delay that. Okay. Another interesting action is the calibration of the EGR valve. Okay, so it's necessary when we modify components of the EGR, or for example, when we have some mechanical symptoms. Okay, it can be symptoms that comes with faults in the ECM or not. For example, if we have a bad fuel combustion, maybe we have to recalibrate the EGR of our equipment. But I would like to highlight another capability of Jaltest is the technical information and troubleshootings that are available one click away. Okay, you will have that integrated in the software. This information is very helpful and save a lot of time in your daily repairs. So for example, I would like to show this with an example in the software. So now I'm going to connect to Jaltest in order to see how we can work with Jaltest and repair one typical active fault in Caterpillar engines, that is the 3360 fault. That is a malfunction in the communication. Okay, so let's go to the software. Okay, let's go to Caterpillar Compat Equipment. Okay, Caterpillar. Once here, we are gonna go to a 900 series, 930. And once here, as you can see, Jaltest is not only covering after treatment system or the engine. We have other elements like the hydraulic systems, transmission, etc. But in this case, we are gonna connect to the after treatment. Okay, so let's connect to the engine. Okay, so another good thing of Jaltest is that help you with the communication. So show you where are located the connectors, what cable we are gonna need. Okay, how is the pin out, all this information. Okay, so this is very interesting. And will save us a lot of time when we are working with off-highway machinery, okay? So once here, we are gonna go to read fault codes. And here we have the fault that was mentioned. And I'm gonna click to troubleshooting, okay? Just we are gonna have an overview in the information that we have displayed in Jaltest, okay? So we have here two troubleshootings, one for the FMI1 and FMI2, so depending on the configuration. But I'm gonna have a look in this one, okay? So let's increase the size and expand all the steps. So all right, so here Jaltest is gonna allow us to perform all the checks, okay? So Jaltest is showing us the checks and the inspections that we need to carry out in order to be able to fix this communication malfunction, okay? So as you can see, we have information about resistance, and more information about the schematics, the wiring diagrams that are integrated one click away. And not only that, we also provide you the steps, configuration, specifications, pinouts, technical information, locations. So you will save a lot of time going exactly to the pin that we need to check to resolve this problem. To track to the cables, we need to see if we have something that is not going on there correctly. Well, all this information, okay, one click away and integrated in the software. So anytime we have a fault, we can click on troubleshooting and we will save a lot of time. So it is very important to have the right key test in the software, but also the same important is to have the technical information and the requirements, okay? So let's go back to the presentation. All right. So well, Jaltest Offhighway also includes all the resets needed in every after-treatment system. So for example, we can modify components of every after-treatment system, as you can see right now on your screen. We can modify elements of the EGR, the DOC, the DPF, or the SCR. And these replacements are gonna ask us to perform a reset in order to let the ECM know that we have a new component working on our after treatment. So these resets are gonna be available in Jaltest. And also, for example, the inducement mode reset, that it's a very interesting capability of Jaltest that provides you in many engines, like for example Dodge, Cummins, JCB, and John Deere, the capability of having like an extra life. Okay, so imagine your machine has start the inducement mode, and you are inside of a mine or working with this in a construction, and you cannot carry out the region or the action needed. So if you have Jaltest, you can carry out this reset. So you will gonna have, for example, I think it's in case where we can have like 30 minutes more of operation without the the derate. So we can drive the machine out in order to perform the region in a safely place, okay? So, well, these resets are very important. And in fact, I would like to show you another example, okay? An interesting reset for Janmar engines that is available in Jaltest, okay? So here you have, when we have this fault, we need to carry out a reset, okay? So we are gonna see this in the software. So let's go back to the software, stationary engines, in order to check this in Janmar. We are gonna go to this, to this 40NV 8C Janmar engine. Okay. Once here we have the information about the connectors. Okay. Let's connect and read fault codes. Okay. So, all right. So anytime we have, no, in this one is not the fault I'm looking for. Sorry, because I'm in the demo mode, and for some reason I do not have the fault that I'm looking for, in which well, because in simulation mode, as I'm working right now, we do not have all the faults. We have some examples. So, okay. So we do not have the example available. So I'm gonna explain you directly on the presentation. So sometimes we have a fault that is related to the high shoot levels, okay? And if we are not the expert in Janmar, probably we go directly to do a DPF region, okay, because we have a high level of shoot, so we perform a region. But the ECM will not allow us to carry out the action because we have active another fault, that is the diesel particular filter active regeneration inhibit, in which the capabilities of doing the region are blocked by the ECM. So this second fault needs attention before performing the region, okay? So in order to be able to resolve the problem, we need to click on maintenance. So I can show you this. Sorry, 1 second. I can show you the action on the software. Just 1 second. So I do not have the fault active, but I can show you exactly the action, okay? So in order to be able to resolve the problem, we are gonna go to maintenance, diesel particular filter, and here we are gonna carry out the values restart of the DPF, okay? Doing this, we are gonna make the ECM knows that the faults are not more there. It's like a reset, and after doing that, we can carry out the region, okay? So this is very interesting and allows us the reset to have this Jammer engine working and operating again, okay? Well, I would like to finish this part of maintenance of the after-treatment system, letting you know that Jaltest cover more than 20 different engines and more than 20 different after-treatment manufacturers, including, for example, Caterpillar, Perkins, Volvo Construction, John Deere, Doist, Case New Holland, Cummins, Liebherr, Iveco, FPT, MTU, Jammar, well, etc. Many of them, JCB. And well, I would like to highlight one of the best things of working with Jaltest is that we do not have limits when we are working with this equipment. So this is something very important, for example, with John Deere, with Liebherr, with Mercedes, where having the diagnostics tool, the OEM software for being able to perform actions on a after treatment is very difficult. They are limiting uh, they are limiting the users to have these capabilities, and the best thing you can do if you don't have the software and you don't have Jaltest is going to the dealer to have your machines back to work. So with Jaltest, you will jump to that dealer level and you will be able to operate in all these brands, okay? Especially, well, John Deere, that is very famous, or Liebherr, okay? So you can run regions, resets, and this type of system checks that we have seen, okay, during the presentation. All right, so what's coming? Well, I would like to finish off the webinar having an overview on what's coming to the industry. So first, the mentioned tier 5, okay, and the following tiers that are coming, because they are gonna be in the same direction. As I said before, the goal right now is to reduce the CO2 emissions, increasing the efficiency of the systems after treatments, okay? So, well, they are gonna focus in the injection. They are gonna increase the efficiency of the injection by controlling the fuel consumption and controlling better the performance of the engine, okay? So the manufacturer will reduce the diesel consumption, as I said, and the waste of energy, in other words, the emissions of our machines, okay? So this new technology, these new capabilities are gonna make that maybe in the future we are gonna have less and less after treatment systems because we have a best engine performance, okay? More eco-friendly, okay? So in the same direction, we are going to see an increase of telematics solutions for off-highway equipment. Okay, so this is I say it in the same direction because the goal of having this telematics implemented in our equipment is to keep the engine performing better, the reducing the diesel consumption, increasing the hours of work, making everything more efficiency. Okay. Of course, I would like to highlight Jaltest Telematics. That is our telematics solution for off-highway. That is different to other telematics tools because it's not only monitoring the fuel consumption or the hours of work, as I say, but also provide diagnostics capabilities. And this is very important, okay? This development will reduce the downtimes of every equipment because with Jaltest Telematics, your technician will be able to read full codes and execute system checks, resets and regions from their shop. So if we are having a derate and we are far from the place that the machine is operating, if we have Jaltest telematics, maybe we can do the reset and the region needed just in one click from our computer, and we will have that machine working back again. I mean, we will be able to repair a excavator in South Africa from Miami. Okay, so Jaltest telematics cover after treatment system, but not only that, we are also having capabilities for hydraulics and other proprietary system engines, of course. So this is something in which the industry is pushing, and we are offering a very good solution that allows you to save time, money, and again reduce the emissions of your company by having always your machines working at its best performance. Okay. Finally, well, as I already said, it seems that we are going to a world without after-treatment systems, and a proof of that that is becoming real is the increase of hybrid fleets, electrical machines, and even new manufacturers with electrical components. Okay, for example, well, we have here the Cobelco SK210H, that is an excavator hybrid. We have also a Caterpillar Z line with the electrical engine, the 323F Z line. Also a Volvo wheel loader, the L25. We have other examples in case, for example, with the 580V backhoe. Also a Caterpillar dozer that is hybrid, that is the D7E. And we are going to find new players in the industry. For example, here I put Cobaco, what is a manufacturer of electrical skid steers. And well, something that we have seen in the off-highway industry is the increase of electrical equipment in material handling, like telehandlers, bomb lifts, scissor lifts, and all this equipment with electrical engines. Okay. So we are arriving to the end of the webinar. I would like to thanks to you your attention. And I would like to conclude my presentation, letting you know that there is a solution for you guys, that is Jaltest Offhighway, that is the best aftermarket solution for working in every after treatment systems. It's a solution that will increase your freedom, will allow you to work in all the makes and all the systems, will provide you technical information, and in other words, we stop you of depending in third parties when you are repairing your fleet, when you are working in your shops. Okay, so well, cover all the system in one solution, repair what you want when you want, and increase your market. Okay, increase your capabilities with a tool that is ready for the future. Okay, so thank you very much for your attention. I don't know if you have some questions during the presentation, but I have had my colleague Marcos there. So, well, if you have any question, I will have a look right now and answer them. So, all right. So we do not have any question, I see. I hope you enjoyed the presentation. Thank you very much for your attention again. Here you have our contact details. So if you have question, if you want to have more information about these after treatment systems in the off-highway industry, you can contact us. And also, we will have this video, this webinar available in YouTube very soon, so you can have a double check in what we have seen today, okay? So thank you again, and well, see you around in the next webinars.